Hi teacher, my name is Perez Lopez Jessica. My final project is about the generation of biogas through biomass. This project I make in biomass with the teacher Burgos, and is to arrive to generate biogas through of biomass. The background, according to CENEL, in Mexico, there is a potential of 3,000 megawatts for generation of electricity with biogas from the recovery and use of methane from animal waste, urban solid waste, and sewage treatment. In 2010, there were 721 biodigesters in Mexico, of which 367 were in operation and 354 were under of construction. 563 biodigesters are financed under the Clean Development Mechanics chain. 154 with support from the Share Risk Trust, and 4 biodigesters through the Methane on Markets initiative. The 8% of the pig farms have biodigesters, of the which 20% have motor generation with the 17 in operation. The total installed power is 5.7 megawatts for the use of the biogas obtained from sanitary landfills. One of the most important experiences in Mexico is that of bioenergy, the Nuevo León. The first and the national level, the system is made up of 7 motor generators of 1 megawatt each. The plant was designed in modular manner to allow for future capacitor additions. In the introduction, through simple calculation, but with its proper structure, it seeks to estimate the generation of biogas that a biodigester can carry out the obtained electricity generation with a demand of 33 kilowatt hours for a family through anaerobic digestion that consists of the decomposition of biodegradable material in the absence of oxygen to give biogas as a result. According to the Mexican Center for Environmental Law, the main environmental problem is climate change, resulting in fire, the danger of ecosystems. Every year, temperature rise due to increase in gas accumulate in the atmosphere that give rise to greenhouse effects. It seeks to give good use to the creation of energy called biogas through biomass. In resume, there are several types of biodigesters that can be used. In the case the induced type is used where anaerobic digestion will be carried out the production of biogas. The induced type biodigester consists of the vertical reactor tank that has a floating biogas collection hut installed. In this way, the pressure of the gas on the surface of the mixture is very low, around 300 millimeters of water column. With this hut, a constant pressure is also achieved, which allows efficient operation of the equipment in feeds. The hood also helps break of the foam that forms in many biodigesters. In this biodigester, volumetric productive of 0.5 to 1 cubic meter of biogas on reactor volume per day are reached. A schematic of such an installation is shown below. The methodology. where anaerobic digestion performs its fourth stage. First, the hydrolysis consists of a transformation controlled by extracellular enzymes in which complex and undissolved organic molecules are broken down into compounds that can be used as a source of matter and energy for the cells of microorganisms. Fermentive or acidogenic stage. This second stage, controlled by bacteria, consists of the transformation of the compounds formed in the first stage into other compounds or intermediate molecular weight, such as carbon dioxide, hydrogen, aliphatic acid, and alcohols, methylamine, ammonia, and hydrogen sulfide. In acetogenesis stage, the acid and alcohols that come from acidogenesis are transformed by the action of bacteria into acetic and acid, hydrogen, and carbon dioxide. Methanogenesis, the last stage, consists of the bacterial transformation of acetic acid and formic acid into carbon dioxide and methane, and the formation of methane from carbon dioxide and hydrogen. In other words, and a little more linked within the biodigester, where microorganisms such as hydrolytic bacteria degrade organic compounds in even a small portion for the better use in the water. With the help of the bacteria, transform this mixture in intermediate products such as alcohol, fatty acid, acetic acid, CO2, and hydrogen. Acetogenic bacteria began to transform organic acid and alcohols into acetate, molecular hydrogen, and CO2. Then after began a touch, the methanogenic archaebacteria enter, producing methane, where they divide into acetoclastic, which transform acetate in methane and CO2, with 17% production of methane obtained, and on the other hand, it is divided into hydrogenotopic, producing 13% of methane approximately. This whole process is important since it gives a balance to the system. Otherwise, the accumulation of hydrogen could block acetogenesis, causing volatile fatty acid to increasing an acidity, which will lead to an inhibition of the process. To terminate, the sulfate-reducing bacteria responsible for the degradation of sulfate contained in the organic matter, to reduce the sulfates into hydrogen sulfide, obtaining a mixture methane, CO2, and hydrogen sulfide. Name it biogas. The organic matter that will be used manure will come from pigs. This digestion will be a mesophilic environment. Since its efficiency range is within 25 degrees centigrade and 45 grades, and the temperature that will be used will be 42 degrees. The retention time will be 18 days because you will be working with a medium temperature and you don't need a long retention time. Biodigester and ecological function by fully recycling organic waste, protecting the soil, stream and rivers, the air and the atmosphere, thus reducing the greenhouse effect produced by waste when it relates uncontrollably into environments. Globally, the availability of energy has become one of the main problems but developed industrialist countries face on growing demand for energy to meet their economic and social expectations. The use of fossil fuels for energy production causes the discharge of toxic substances into the air, water, and soil, affecting the nature. The dumping of organic waste into the environment causes contamination of the soil and water sources, emits unpleasant odors, and produces high concentration of gases, and promotes the proliferation of vectors and pathogenic microorganisms with the consequent negative impact on the environment. The production and accumulation of manure causes other derived problems. Among these, emissions to the atmosphere due to decomposition of the waste, in some cases no nuisance to the population, emission of the greenhouse gases due to its contain a pollution organic loads. These wastes produce ammonia and leaches that can contaminate aquifers with nitrates and nitrites, harmful to health. Therefore, taking advantage of organic waste in biodigesters is extremely positive for the environment, together with the production of renewable energy that can replace the consumption of fossil fuels. At present, a large number of agro-industry companies are considering the organic waste generated daily as a high-value product, which can be used economically, improving to the competitiveness of agro-industrial farms. Additionally, a project of this nature represents an excellent business opportunity to commercially reinforce its image of social and environmental responsibility with the consumers. The steps to make the calculation of this project start with the data to use are, in this case is the peak, amount scraped per day are 2 kilograms, biogas yield 0.07 cubic meter scraped, having a manure water ratio of 1:3, a retention time of 18 days, total day manure production, numbers of peak are 2. This will be 617 by 2 is 1,340 kilograms on day. Amount of water required: 3 liters of water by 1,340 is 4,020 liters on day. Total biomass available in cubic meters is daily manure production more amount of water required are they are 5,316 liters on day or per day. Volume of biomass to be degraded. For this part, the retention time in which biomass will be inside the bioregister is taken into account. Is 5.36 cubic meters by 18 days is 96.48 cubic meters. Volume of biogas is manure production by biogas is in cubic meters 2. Total volume of biodigester is 96.48 cubic meter more 93.8 is 187.6 cubic meter. The production of electrical energy. In order to solve this section, the calorific value of the biogas must be known, which is 6.5 kilowatts hour on cubic meter, and the electricity generated by day is 6.5 by 93.8 cubic meter is 609.7 kilowatt hours. CO2 emission. For this part, it is necessary to know the CO2 emission factor for electrical energy, which is 0.454 kilograms of CO2 on kilowatt hours. In total of CO2 generated are 276.1838 kilograms of CO2 generated. The results. To verify that the data is correct, the energy will be removed. Electric energy generated on rotation times, that they are 33.8722 kilowatt hours on day. To transform this date to annual generation, what follows is to know how many times a year we must carry out the same process, and we do this by dividing the numbers of the days in a year by the retention time of biodigester, which is done follows. There's 365 days of the years. On 80 days of retention is 20.2717 days. What follows is to know how much energy will be produced with the amount of the annual process, which is done as follows. 20 by annual process, energy for each process, that is 609.7 is 12,000 kilowatts hours. Now we are looking to know how much biogas is needed to generate all the electricity. 20 by 93.8 cubic meter is 1,826 cubic meter. Finally, to know the annual CO2 emission it is enough to multiply the emission produced in a single process by the number of processes that must be done per year, which is done in the following way. The economic viability. Next, we will proceed with a quotation for electricity generation without using the service of CFA if we use a rotoplas type biodigester with a capacity of 12,000 liters for cubic meter. The number of biodigester required, the total volume required on volume of available biodigester. Since we have the number of biodigesters, it's necessary to supply and taking into account the cost per unit of biodigester. The number of the biodigester is multiplied by the cost per unit, which give us a total price of 1 million approximately. To make a comparison with CFE, CFA calculation will be made to see how much will be paid for the same energy consumption required it approach already carried out, taking into account the F1 collection rate in the winter. So we know that our consumption is 12,000 kilowatt hours. This is divided and it will be as follow. This that 12,000 on 12 months is 1,015.1566 kilowatts hour per month. First rate are 0.837 by 1775 is 62.775. Second rate is 1.012 by 15 is 15.6. The third rate is 2.962 by 891.1616 is 2,639.6354. Given a monthly cost are approximately 2,753.0100 and an annual cost of 33,000 approximately pesos. We can see that there are higher costs from biogas. If you look at it from the short-term point of view, it's more expensive and therefore less economically viable. However, if you look at it from the medium-term point of the view, it will be a great help for our capital. Since that is one of the main objectives, along is with its efficiency as an energy and its great help to environment. Our conclusion: so the energy from biogas is not so economically viable if viewed from the short-term side, but if viewed from the medium-term side, it's an excellent alternative, as already mentioned above. This energy over time will have improvements as the older have evolved over time. That some situation that will help to evolve will be the people who sufficient income could invest in trading. It's a necessary place as they are have sense in farm, etc. And those people sponsoring the money as they got better they were recognizing in some way in order to encourage them to follow such a plan. It is important to care about the environmental. Conventional energy that we have always been to exploit are not finite, so we have to invest time and money to support these energies, because let's imagine that with type of protection is never listened to, then a more critical moment arises where we don't even have where to get a fossil fuel. What will happen? The cost will rise as we already know, and it's happened little by little. That rate will rise. Personally, I will not be on a biodigester. Time is time of life. Since I don't have the resource to take care of it, nowhere to get organic matter, nor the money to make the investment. but for the future, if would like to work on it, know it in a more practice and not only theoretically. I hope to be able to give an innovation, even if it is not a such big one, only if it works. The SWOT, the strengths of carrying of this project are that and I can carry of this type of project with certainly because I know what I am talking about. I can easily perform the calculation in a many types of environments. My weakness of the project is that I don't have the capital to be able to make the first investment. The opportunities I have from the project and private companies can hear me to carry it on a place or a space where animal excrement is a begin waste. The trace of this project is that some governments regulation can change, so that it affects the standard of energy production that it can supply the land, and that it's all for me. Thanks for your attention, teacher.